So today we're going to be doing a problem. It'll eventually look like this. And we're going to work through all these steps to find the percentiles to accommodate 95% of users. So we'll begin. The Army is designing a new adjustable chair for its service members. They have tasked you to ensure that it is designed ergonomically and fits 95% of users. Find the maximum and the minimum settings that should be used for the seat height and the elbow rest height to ensure that the vast majority of users can use the chair comfortably while maintaining good upright posture. So we're going to do this in two steps. First, we're going to calculate the maximum and minimum seat height for the adjustable chair to accommodate the 95% of service members, with the assumption that both feet are flat on the floor and the shoe soles are 2.5 centimeters, and then assuming the seat cushion is 8 centimeters tall. And then we're going to calculate the maximum and minimum elbow rest heights for the armrests of the adjustable chair to accommodate 95% of service members again. We'll assume that soldiers can comfortably sit with their elbows making a 90-degree angle. So we'll begin with a given chart. So in any problem like this, they'll give you a chart with either a 50-50 mixed population or a population for males or females. So this one is 50-50. So we just have to do 95% of users within that. So first we have to calculate the 95% of users. So here we can see the mean and the standard deviation, and this is the fancy formula for calculating the 95%. So we're going to look up the 2.5th percentile and the 97.5 percentile using a z-table. So the z is required for this formula. So you can see here, z equals x minus x bar over the standard deviation. So we'll write that here. Z equals x minus x bar over the standard deviation. Okay. So to find the 2.5th percentile, we're going to, it's the same for anything over 50 and anything less than 50. You just find like the 2.5th percentile is going to be the same as the 97.5 percentile. So what you do, you go down here, we're going to look for 97.5. So whatever's closest. And luckily for us, 97.5 is exact. So usually we would just pick the one that was closest. If there was one that wasn't exactly closest, we would just choose one of them. So here, this means 1.9 over in this section, and then 0.06 in this section. So using the z-table, we know that the z-score for 0.975 and for 2.5 is 1.96. So it'll be negative 1.96 for the 2.5th percentile and 1.96 for the 97.5th percentile. And this is, again, for the popliteal height. So to find popliteal height is the, so that's the distance between the lower part of someone's thigh and their shoe on the ground, where their foot touches the ground. So we're also going to have to accommodate for this 2.5 centimeter shoe sole height. So we're going to use this formula right here to calculate popliteal height. We're looking back at the known chart that was given to us at the beginning for mean and standard deviation. So you can see popliteal height is a given, 41.9 and then 3.4. So we're going to write this out. So x bar equals 41.9 centimeters. Standard deviation equals 3.4 centimeters. So then that means that z, from this equation, z equals x minus 41.9 centimeters over 3.4 centimeters. So we're going to have one for the 25th, my mistake, the 2.5th, and one for the 97.5th percentile. So let's see. So then we're going to end up inserting the z-score. So then that for the 2.5th is negative 1.96. So that's x minus 41.9 centimeters over 3.4 centimeters. And if we cross multiply and then add the 41.9 centimeters, that gives us x equals 35.236 centimeters for the 2.5th, which means that for the smallest person within that, like the 2.5th percentile, so very small person, this will fit them. So this is going to be our minimum. So then we also have to add the 2.5 centimeters for the shoes and subtract the 8 centimeters for the seat cushion. And this is because if we look at this model, the chair, the person sitting in the chair, this is going to be 8 centimeters. And then the shoe sole height, so their shoes right here, is going to be 2.5 centimeters. So we need to add 2.5 centimeters to accommodate for this right here, and then subtract the 8 centimeters to accommodate for the additional seating right here to find the minimum for the person that would be there. Then we're also going to do the same thing for the 97.5th percentile. So now instead of negative 1.96, it's going to be 1.96 equals x. Here, I'll draw a line. 1.96 equals x minus 41.9 over 3.4. X equals 48.564 centimeters plus 2.5 centimeters minus 8 centimeters. This is for the seat cushion again, this is for the shoes. And both of these give us 29.7 centimeters and 43.1 centimeters. So the lowest setting of the chair height should be 29.7 centimeters, should be the lowest, and the highest should be 43.1 centimeters off the ground to ensure that 95% of soldiers can comfortably use the chair. So that's this height right here from the base of the cushion to the base of the floor should be within this range. So the lowest setting is going to be 29.7 centimeters. The highest setting is going to be 43.1 centimeters. All right, so here we are for part B. We're going to calculate the maximum and minimum elbow rest height for the armrest of the adjustable chair to accommodate 95% of service members. So we assume that soldiers can comfortably sit with their elbows making a 90-degree angle, as shown in the picture, meaning that their arms will be at elbow rest height. So we know from the previous one that to accommodate 95% of users, we need to accommodate the 2.5th percentile and the 97.5th percentile, because that combined will accommodate the 95. Even though it's a little counterintuitive, you would think it would be 95 and 5. That would only accommodate 90%. So to accommodate 95th percentile, you have to do the 2.5th and the 97.5th. So like we did before, it's the exact same z-value. So we got that from the chart. It's negative 1.96 for the 2.5th and regular positive 1.96 for the 97.5th. Then we got the x mean value from this chart, which would be given to you in any problem you would do like this. So this is elbow rest height, and 23.6 is the mean, 3.0 is the standard deviation, and that's what we have here. And this is in centimeters. If it was given to you in anything other than centimeters, you would just want to convert or keep your units consistent to report your answer in whatever the problem told you to report it in. For this, it didn't tell us, so we're just going to keep it in centimeters. So for the 2.5th percentile, we're going to do exactly what we just did. Using this formula from above, z equals x minus x bar over standard deviation. So that'll be negative 1.96 equals x minus 23.6 over 3.0. X equals 17.72 centimeters. For the 97.5th percentile, it's the exact same formula, except we're going to have 1.96 instead of negative 1.96. and then the exact same numbers on this side. So then we're going to cross multiply, add the 23.6 to both sides, and we get here x equals 17.72 centimeters, and here x equals 29.48 centimeters. So what that means is that the lowest setting of the elbow rests should be 17.72 centimeters above the top of the seat, because this was derived from elbow rest height, which is from the seat to the elbow rest, above the top of the seat, and the highest setting should be 29.48 centimeters above the top of the seat. So that will accommodate the 2.5th percentile and the 97.5th percentile, so a tiny person and a huge person, which will accommodate 95% of service members overall. So combining these two together will give you the information necessary to give the Army the new adjustable chair it's looking for.